Hello, welcome to Nomis Academy. In this video, we are going to be looking at cycle theorems. So now let's pick the first theorem, which is theorem 1. We are going to state the theorem, and at the same time, we are going to prove the theorem. Then in the subsequent videos to come, I'm going to give examples under theorem 1. So let's state the theorem and then make the proof. So it states that the line which join the center of a cycle to the midpoint of a chord is perpendicular to the chord. Okay, this is theorem 1. It says that the line which joins the center of a cycle to the midpoint of a chord is perpendicular to the chord. So now let's take the diagram. We have a cycle. Okay, this is a cycle. Now this is the center of the cycle. We call the center O. Okay, and then we have a chord AB, and then we said the line that joins the center of the cycle to the midpoint. Let here be the midpoint. So we call this T. We call the midpoint T. So that line is said to be perpendicular to the chord. So when we talk of perpendicularity, we mean that the angle formed at that point is 90 degrees. Okay, now let's go further to show the proof. So given, we are going to follow the procedure. We are given a cycle with chord AB and center O. Okay, that is what is given to us. Now we are to prove that angle ATO is equal to angle BTO, and then it is equal to 90 degrees. So this is what we are about to prove. We are to prove that the angle formed at that point is 90 degrees, to state that the line that joins the center of the cycle to the midpoint of the chord is perpendicular. So now let's continue. Construction. We're going to join O, or draw a line. Draw line OA and line OB, which is called the radii of the cycle. All right, so the next thing is to prove. So when you do that, you join O to A and join O to B. Okay, so you can see we have two triangles in the cycle. We have triangle OAT and triangle OTB. Two triangles. So the triangles OAT and OTB. So let's consider these two triangles. So the first thing we will consider is AO is equal to BO, and it is called the radii. So they are equal. Line OA and OB are equal. Okay, and they are called the radii of the cycle. We also have OT also equal to OT, which is the common side. So these two sides are common. And then we also have line AT, which is also equal to line TB. Okay, which is the midpoint of the chord. Or we say the bisection of the chord bisection. Okay, so you can see that AT is equal to TB as stated. Now, we can now state that the triangle OAT is congruent to triangle OBT, and then the congruency is SSS, meaning that the three sides of the triangles are equal. So it now implies that if the three sides of the triangles are equal, so we can also say that, therefore, we can say that triangle AOT is equal to triangle BOT. So the two triangles are equal, and then also implies that the angle OTA, that is the angle at this point, is also equal to OTB. That is the common angle. They are equal. So we still proceed to say that OTA plus OTB is equal to 180 degrees. That is some angles in a straight line. Sum of angles in a straight line. So from there, each of them can be written as follows. OTA is equal to OTB, which is equal to 180 over 2. And then we have 90 degrees. So we have 90 degrees. So it means that that particular line OT is a perpendicular line. So we go back to the theorem that says that the line that joins the center of the cycle to the midpoint of a chord is perpendicular. So we've done the proof. Thank you for watching, and see you next time. Bye.